Okay, can you see the screen?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Okay, so this was the speed torque characteristics of a DC shunt motor, where the top one was the rheostatic, or sorry, natural speed torque characteristic, wherein the armature circuit resistance was equal to the armature resistance only, without any external resistance. And as you go on adding external resistances, we had seen that the speed torque characteristic goes on shifting. So we were learning how to draw these speed torque characteristics. We had seen that we need 2 points. If we take this one as the nominal torque, and this will be 1 point. And this is 1 point that we have to find. And then the second point is the point at no load, or corresponding to the no load speed. So we had seen that for this point, the nominal or rated speed can be obtained from the nameplate of the motor, and the nominal torque can be found by using the equation P nominal is equal to C multiplied by IA nominal, where C is equal to K phi. We'll see later how to find the value of C. Correct? And we had also seen how to find the value of omega 0. Correct? This was the equation. If you remember, omega 0 is equal to V upon K phi. That can be written as V upon V minus IA nominal R armature multiplied by omega nominal. So this was the no load speed. We had also seen how to find the armature resistance, that is approximately equal to 0.5 into 1 minus the nominal efficiency multiplied by V upon IA nominal. We've taken use of the fact that the armature resistance can be determined approximately by assuming that half of all the motor losses at rated load are accounted for by the armature copper loss. Okay, so in this way we could obtain the natural speed torque characteristic of the motor, and then for obtaining the rheostatic characteristic, the no load speed remains the same, the nominal torque remains the same. The only thing that has to be found here is the speed, omega RH under nominal conditions. So this omega RH nominal is given by omega 0 into 1 minus IA nominal multiplied by the armature circuit resistance that now includes the external rheostatic resistance divided by V. I think we had completed till here. Is that correct? Yes or no?
Yes, sir.
Yes, sir. Today we'll move forward. Okay, now the speed torque characteristic. One way to obtain is by using these 2 points, correct? Another way to obtain this speed torque characteristic is by using this point and this point. Correct? This is the point of the ideal no load speed, and this point corresponds to the short circuit of the armature, where the motor torque is equal to the short circuit torque and the speed is 0. Okay, is this clear? One way was to obtain these 2 points, this point and this point, and another way is to obtain this point and this point, or the intersection along the y-axis and the intersection along the x-axis. And the intersection along the y-axis, we have already seen how to find omega 0. The only question is how to find out this point. So how to find out this point? Here the speed is 0. The only thing you have to find is torque. And the torque can be found by using the equation. Which equation? What can we make use of? Yes, anyone? What
Sir,
can we
what you
make?
are asking? Sir, what you are asking?
I'm
At
asking how to find this point. TSC. How to find TSC? Short circuit torque.
she was at
So
which
by block rotor test,
speed is equal to 0.
By block rotor test. Yes.
Speed
Anyone
is 0.
else? Without going into block rotor test.
Block auto test.
Sir, omega is equal to omega naught minus E into that equations.
Sir,
Omega is equal to omega naught minus delta
E
omega.
sir,
omega naught into 1 minus
minus
T by
delta
Ts.
Omega naught into 1 minus
T by Tsc.
T by TSC. Omega naught into 1 minus T by TSC. But how to find TSC, man? That is the question. Omega is equal to omega naught 1 minus T by TSC. Here omega is 0. That means 1 minus T by TSC is equal to 0 or T is equal to TSC. So that does not answer our question. How to find TSC? Short circuit torque without going for the block rotor test.
So Tsc should be equal to T nominal into Isc by I nominal.
Correct. By making use of the fact that because the flux is constant, the torque is proportional to the armature current. है ना? That is why TSC upon T nominal will be equal to ISC upon I nominal, or TSC is equal to T nominal TSC is equal to T nominal multiplied by the short circuit armature current divided by the rated armature current. है ना? Quite simple actually. Now we know the rated armature current. We also know the rated torque. The rated torque is given by C into IA nominal. So these two are known. How to find the short circuit current? ISC. What will be the value of the short circuit current? ISC. At this point, what is the value of armature current?
That's into V upon
So B by R. Sir.
Yes, it is V by R. है ना? Because under short circuit conditions, we have omega is equal to E upon K phi, that is V minus IAR upon K phi, and under short circuit condition, the speed is 0, and the speed will be 0 only when V minus IAR is equal to 0 or IA is equal to V upon R. Where V is the applied voltage, which we are assuming as constant, and R is the armature circuit resistance. So, for this characteristic, ESC will be equal to V upon the armature resistance. And because the armature resistance is very small, the value of the short circuit torque will be quite large. As you go on increasing the armature resistance, as you go on increasing the armature circuit resistance by adding external resistance in the circuit, the short circuit torque goes on decreasing. Okay. Each rheostatic characteristic will have its own value of the short circuit current ISC and short circuit torque ESC. Okay. So this point we have already seen how to find, and this point can be obtained if you know the value of the armature circuit resistance. If you know the value of armature circuit resistance, the short circuit current is simply equal to V by R, and then the short circuit torque will be equal to the rated torque multiplied by the short circuit current and divided by the rated or nominal current. Okay, so this is also one way that by which you can find out the speed torque characteristics. Is this clear? Yes.
Yes, sir. Yes, sir.
Yes.
Yes, sir.
Now this speed torque characteristic equation, this the equation of this line can also be written in the following form. What form? Omega is equal to omega 0 into 1 minus T by TSC. How do you obtain this? This is the line, suppose.
So from the graph,
What is the slope of this line? Y2 minus y1 divided by x2 minus x1. So the slope of this line will be minus y0 by x0. Minus y0 by x0. So the equation of this line is y is equal to minus
Minus R
y0
is
by x0 minus y0 by x0 into x plus the y-intercept, that is y0. So y becomes equal to y0 in bracket 1 minus x by x0. So in terms of our parameters, that equation becomes omega is equal to omega 0 1 minus e by dsc. Correct? So when torque is 0, omega is equal to omega 0. When torque is 0, omega is equal to omega 0. And when torque is equal to the short circuit torque, T is equal to TSC, this becomes 0, so omega is equal to 0. So when torque is equal to the short circuit torque, omega is equal to 0. Okay. Now an equation for the motor speed torque characteristic can also be written like this. Omega is equal to E upon K phi. And where E is equal to V minus IAR. Omega is equal to V minus IAR upon K phi. Now we can take out V upon K phi from here. So we are left with 1 minus IAR upon V. Correct? Now this V upon K phi is nothing but the no load speed omega 0, as we have already seen. So omega becomes equal to omega 0, 1 minus IAR upon V. Now we can divide both sides of this equation by omega 0. So the left hand side becomes omega upon omega 0, and the right hand side becomes 1 minus IAR upon V. Now this omega upon omega 0 is nothing but the per unit speed that we have denoted by small v. Now this v can be written as 1 minus, we are dividing both the numerator and denominator by the nominal current. So 1 minus IAR upon IA nominal divided by V upon IA nominal. What is IA upon IA nominal? What is IA upon IA nominal?
That is means how much knowing.
per unit,
I per unit 2.
Correct. It is the per unit
Per
current.
unit.
That can be written as small I.
क्या होना चाहिए सकते हो
Okay. IA upon IA nominal is the per unit current, per unit armature current, that can be written as small I. What is V upon IA nominal? V upon IA nominal.
Per unit R.
R armature resistance.
Which resistance?
Armature.
Armature. What is this armature? What is V upon IA nominal?
R nominal.
Nominal.
Means input current is this much and voltage is this.
Nominal armature resistance.
It is the nominal armature resistance, which in simple terms we call as the base resistance. Correct?
Yes, sir.
Base resistance. And then this R divided by the base resistance, that becomes the actual resistance in ohms divided by the base resistance in ohm, that becomes the
Per unit.
Per unit resistance.
per unit resistance. That is why this equation now becomes V is equal to 1 minus small I into small r. Where small I is the per unit armature current and small r is the armature resistance in per unit. Okay, is this clear?
Yes, sir.
Okay. Now, in case the flux is constant, which we are assuming that it is constant, है ना? So in case the flux is constant, this equation can also be written as V is equal to hmm, it can also be written as V is equal to 1 minus mu R. I was the per unit armature current. What is mu? Yes, the flux is constant. This equation can also be written as V is equal to 1 minus mu R. What will be mu? It is the torque, per unit torque. Correct? Torque is equal to, torque is proportional to phi into Ia.
I into I.
Sir,
Yes,
sir, mu means current or
mu is torque, mu is torque. I is the current, mu is the torque.
current? Mu is torque. Okay, okay. Thank you, sir.
So, as I was saying, if the flux is constant, then torque is directly proportional to the armature current. Okay? So, instead of per unit current, we can also write the per unit torque. So, are these equations clear to you? What is V? What is small v?
Voltage, sir.
Voltage, sir. Voltage.
It is voltage.
Small v is
Per
per
unit
unit
speed.
speed.
Per unit
I
speed.
need
Here,
omega.
Per
here
unit
it is,
speed.
it is right here. Small v is equal to omega upon omega 0. That is the per unit speed. Small I is the per unit armature current. Small mu is the per unit torque of the motor. Small r is equal to capital R divided by the nominal resistance of the motor, and that is the resistance in per unit. The nominal resistance of the motor is equal to V upon Ia nominal. Okay. How do you define the nominal resistance of the motor? Capital R NOM, that is equal to V upon Ia nominal. How do you define this nominal resistance? Anyone?
Sir,
The rated
Sir.
when the motor is run with rated current, then the resistance of.
When the motor is run with rated current, then the resistance is the nominal resistance of the motor. This is what you
Sir,
are saying.
sir, nominal current means no load voltage or no load current or nominal current.
Nominal resistance means no load current.
Yes, yes.
Only armature resistance. Excluding the rheostatic resistance.
Ia means armature current, sir.
Nominal resistance, capital R.
Yes.
Capital R suffix nominal or rated, that we are saying is equal to V upon Ia nominal. How do you define this? Somebody said that nominal resistance of the motor is the resistance when the motor is running at rated speed. Correct? But that is the wrong definition.
So when rated current flows, the ratio of voltage to that current.
When rated current flows, the ratio of voltage to that current.
Terminal voltage to that current.
That is the wrong answer. It says that, the equation says that, but the answer is wrong. Define. And define means you should be able to find the nominal resistance through that definition. The answer is here in this diagram that we see on the screen. Or in the equations that we have just seen. Yes, anyone?
Sir, it is a ratio of rated voltage with rated current.
So it is only the armature resistance, including the it means not considering the external.
The resistance for which the current will be rated current when we apply the rated voltage.
Rated current when we apply the rated voltage. Now see this rated current, your current is changing. When you are applying the rated voltage, the current is changing depending on the load.
No, sir.
Correct. When your load changes, your current is also changing. It's not that when you are applying rated voltage, you are getting rated current. You are always applying
No,
the
for
rated.
which resistance will
You are always
for which
applying the
resistance will get that value?
rated current. You will get for different values of resistance. Rated current you will get for different values of resistance depending on the load.
Okay, sir.
Even if you change the resistance, you can get the rated value of current if you change the load. I know. But definition
Yes.
means it has to be properly defined.
Sir, at
It has to
rated
be
load,
known.
rated voltage is applied.
So
Then
average of minimum and maximum allowed values.
Yes, Sumit.
So average of the minimum and maximum allowed values.
अरे नहीं भाई, no. Maximum allowed value is the rated. The answer is here. It is there in front of you. Okay, here. You can
So
see the
slope
answer.
of the speed torque characteristics, sir.
No. The answer is the nominal resistance of a DC motor is defined as the resistance which limits the armature current to its rated value when the armature is locked and rated voltage is applied to the motor. The nominal resistance of a DC motor is defined as the resistance which limits the armature current to its rated value when the armature is locked and rated voltage is applied to the motor. R is equal to, how much is R? V upon Ia nominal. And where will you get this? You get it at this point.
Omega equal to 0.
From this you can find the nominal resistance of the motor. Under this condition, you have applied the voltage, and if rated current is flowing through the motor, then the value of the resistance at this point is the nominal resistance. Okay? This point does not depend on the load. Does it depend on the load? ESC. Does the short circuit torque depend on the load?
No, sir.
No. And at the short circuit torque, we've already seen that the speed is 0. So V minus IAR is equal to 0, or V is equal to IAR, or IA is equal to V by R, or R is equal to V upon IA. So at this point, if you're applying the rated voltage and rated current is flowing through the armature, then the value of resistance is the nominal resistance of the DC shunt motor. Okay? Think about it later. Okay, so we have two equations here now. One is V is equal to 1 minus IR, and the second one is V is equal to 1 minus mu R. Both these equations are in absolute values or per unit values.
Per unit.
per unit values. Where on the left hand side you have the per unit speed, and on the right hand side you have either the per unit armature current or the per unit motor torque and the per unit armature circuit resistance. This per unit armature circuit resistance includes your armature resistance as well as the external rheostatic resistance.
Sir, sir,
Hmm.
sir, UR means the voltage drop or
Arey Baba, this is not a voltage equation. This is a speed equation.
okay, okay, sir.
Per unit
Sir,
speed.
sir,
V is
which
not voltage.
which motor characteristics, sir?
DC
DC.
shunt motor.
Yes, yes.
We are in DC shunt motor now.
Okay, okay, sir.
Okay, do not get confused, all of you. This V is not for voltage.
Okay, okay,
Okay?
sir. DC shunt motor. Okay. Sir, one means one minus UR is means is voltage dropper, sir.
Arey Baba, once again, it is not voltage, it is the drop in speed. V is the per unit speed.
Okay,
Yeah,
sir.
here we are defined omega upon omega 0 is equal to V.
Okay,
Okay?
okay, sir.
My wife is saying that even she remembers now. Okay? You also should remember now. V is the per unit speed. Okay? I is per unit armature current, mu is the per unit torque. Okay? This is the mixed equation. Okay? Mixed equation means on the left hand side you have mechanical terms, speed. On the right hand side you have electrical terms. Is this clear? Yes or no?
Yes, sir.
ठीक है. So my question is, in both of these equations, what is this? What is the second term? In this equation, what is IR? And in this equation, what is mu R? What is IR and what is mu R?
So per unit impedance and per unit power.
No. Power can't say from where has power come? Torque into per unit torque into per unit resistance. That does not become per unit power. What is IR and what is mu R?
So relative drop in speed.
Correct. That is the right answer. That is the speed drop in per unit. Correct. At no load. At no load, what is the value of I? At no load, what is the value of I?
No load current, sir.
How much it is?
No load current, sir.
And we assume it as 0.
1.
At no load, what is the value of small I? Can we assume it as 0 or do we assume it as 1?
So very close to 0.
It's very close to 0. Right? If you neglect the no load current, it is 0. Okay? Similarly, at no load, the value of mu is 0.
0.
Right? The motor torque is only to provide for the rotational losses. So if we neglect the rotational losses, at no load the value of I is 0, at no load the value of mu is 0. So at no load, V is equal to 1, or speed in per unit is equal to 1, or the rated speed. Is this clear? At no load the speed is 1 per unit. At no load, this is the no load point. At no load, the speed is 1 per unit, omega upon omega 0. At no load, omega is equal to omega 0. So omega 0 upon omega 0 is equal to 1. So at no load, the speed is 1 per unit. Now, as you go on increasing the load, the value of I will go on increasing, the value of mu will go on increasing. As you go on increasing the load, the speed will go on decreasing. So this was the no load speed, 1. This is the drop in speed in per unit. The actual speed is equal to the no load speed minus the drop in speed in per unit. ठीक है, this clear? Yes.
Sir.
So this term can be written as del B. This term can be written as del B, drop in speed in per unit. So del B is equal to IR, or del B is equal to mu R. Okay. What happens at the rated motor torque? At the rated motor torque, what is the value of small I? At the rated motor torque, what is the value of small I?
1.
1.
1.
Mu is also 1. Okay. So what is the drop in speed in per unit at the rated motor torque?
R. Per unit resistance.
Per unit resistance. Okay. So at rated torque, the relative drop in speed is equal to the relative resistance of the motor armature circuit. Okay. At the rated motor torque, the drop in speed, the per unit drop in speed is equal to the per unit resistance of the motor armature circuit for a DC shunt motor. That is why it is essential that your motor armature resistance must be as small as possible if you want your speed regulation to be good. Okay? One important thing that we learned from this is your per unit drop in speed for a DC shunt motor is equal to the per unit resistance of the armature circuit. As you go on increasing the armature circuit resistance, your per unit drop in speed goes on increasing. Okay, any questions? Yes. Any questions?
Sir, he means voltage or speed, sir.